So the first thing we need to do is checking the GBP and slew rate. So GBP is the gain bandwidth product. So it's literally just gain times bandwidth. And slew rate is amplitude of the output times the frequency in radian per second. So how we're gonna, so let's check the gain bandwidth product first. So the gain is V out over V in, or the output over input. So we'll have 4 volt over 22 millivolt. So that's going to be 0.022 volt. And if you have to calculate that, you should get about 182. So that 182 is our gain. And we're gonna, so for gain bandwidth product, we will do gain times bandwidth. So 182 times the 1500 hertz. So make sure that the bandwidth is in hertz for GBP. And if you do that, you should get 272,727. And the typical op-amp have 10 to the power of 6 for their gain bandwidth product. So, since 10 to the power of 6 is bigger than smaller than, we need to make this smaller. So what we do is we can actually use 2 op-amp. So each op-amp will have a square root of 182 gain. And so we'll have 2 of them. So if you do square root of 182, which is about 13.49, so 13.5. So let's try 13.5 times 1500. So this is when we're using 2 op-amp. And we should get something like 20,000, which is smaller than 10 to the power of 6. So if we use just 2 op-amp, we should be fine. So now that we know how many op-amp we can use, let's check the slew rate. So slew rate is just the amplitude. So 4 volt times the omega, which is 2 pi 1500, and we should get 37699 volt per second. And that is equivalent to 0.0377 volt per microsecond. And typical op-amp has about 0.5 volt per microsecond of slew rate. So since our slew rate is smaller than this op-amp, we should be able to use the op-amp we are using. And if the slew rate that we use happens to be bigger than the specification of the op-amp, we should be using different op-amp that has a bigger, better performance. And now we just need to build a circuit. So we'll have 2-stage op-amp, and typically they look something like this. Where this is our Thevenin, our bias, R1, R2, our bias, R1, R2, but we're going to call it R1 prime, R2 prime to distinguish. Okay. And we should have VCC over here. Since our output is about 4 volt, we can have something like something bigger than 4 volt. So 5, 6, 7. For here, I'll just use 7. So negative 7 volt plus 7 volt, negative 7 volt plus 7 volt. Okay. So how do you figure out the each value of this resistance? And we have this handy dandy formula, which is gain is equal to 1 plus R2 over R1 over here. And we're going to actually make both of them have the same gain of square root of 182 or 13.5 on each. So we're going to have R2 prime over R1 prime. And we can just pick value for R2 and R1. So since it has to be 13.5, we can pick something like R2 is equal to 125k ohm and R1 is equal to 10k, something like that. And for R bias and R Thevenin, so we say the Thevenin resistance is between 5k and 10k. Let's just choose, you can choose like 7.5k too, like it's like in the middle, but I'm just going to choose R Thevenin is equal to 5k. And now we just need to calculate for R bias. And how we get them is through this equation of R2 parallel R1 is supposed to be R bias plus R Thevenin. And if you just calculate that, so it would be 125k parallel to 10k, which is product over sum. So 125k times 10k plus, over 135k. And that should be equal to R bias and R Thevenin. So our R Thevenin was 5k, and it should give us RB. If you figure that out, and you should get RB is equal to 4.26k. And then there you have it. We have the gain bandwidth. We have proper gain bandwidth product with a NS slew rate, and we use 2-stage op amp to amplify the signal from 22 millivolt to 4 volt.